so welcome to week 6. So this is the final week where we go through the last bit, which is geometry. Sorry, it's a few days late. I hope your maths exams went well, that you've had so far. We're going to look at circle theorems, and then we're going to look at some proofs and trig, and it's a bit of a chunky topic. So split it up, look at this video in small bits, and try all the questions first. Okay, circle theorems. Have something similar to this around you. And as you use it in questions, you'll learn it. Don't stress about learning it, just have a poster, write it all out, keep copying it in every time you use it in a question, and by the time you come to the 10th question, you'll know your circle theorems. Okay, so here we go. We've got A, B, and C are points on a circle. We want to work out the size of this angle over here, y. And we're going to look at this shape, and hopefully you'll notice that it looks a little bit like this arrow. So we've got like an arrow shape. Now the arrow rule is that the angle at the center, so this is the angle at the center, which is x plus 62, is twice, so 2 times, the angle at the circumference. So if we open this all out, we'll be able to solve this. So we'll get 3x equals, and we'll be able to solve it 4x. So that's what we're going to start by doing. So if we take this one, we've got, so we get 4x minus x to give us 3x, and then we're going to have 162, and x is going to be 162 divided by 3 to give us 54. So that means we can now work out this angle at the center. So 54 plus 62, which gives us 116, is that angle over there. Now, what we should notice is that within this triangle here, we've got 2 sides which are the same because they're going from the center to the circumference. So both of them are radiuses. And we also know that the base angles of an isosceles triangle are the same. So we've got 116 plus 2y has to be 180. So 2y is going to give us 180 minus 116, so 64, and y is therefore 32. So we've got 32 degrees. Okay, next one. So in this question here, we've now got a tangent. So now we kind of think, what are my rules with my tangent? So we could have the tangent at, meets a line from the center and makes 90 degrees. That's one of them, so that's one of the rules. We haven't got 2 tangents, so we don't worry about this one. And then we've got the alternate segment theorem. Now, the alternate segment theorem, we've got to think about a whole triangle. I know this is split into lots of triangles, but the triangle there. And what the alternate segment theorem says, so if I get rid of this line, is that you've got an angle, you go into the triangle and you go across, and this bit here therefore is the same as 3x. Now if we knew this one, we go into the triangle and across, so the whole of that A would be the same as whatever is there. So we know that CBA equals 3x. So all of this here, this whole thing here, is the same as this, and that's using the alternate segment theorem. It's not a proof, so we don't need to write out all the different steps. So that means OBA, so this angle over here, must be 3x minus 37. So we've got 3x minus 37. We also know we've now got the same as before, an isosceles triangle. This is also 3x minus 37. So OBA is that, which is the same as OAB. We know that angles in a triangle add up to 180. So we've got 2x plus 46 plus 3x minus 37 plus 3x minus 37 equals 180. So now we can collect our like terms. We've got 2x plus 3x to give us 8x. We're going to take all the numbers to the other side. So 180 plus 37 minus 46 to give us 208. And then we can divide by 8 to give us 26. So we get 26 degrees for that angle. Now you've got a question that looks a little strange. There's lots of things here, so let's read it through carefully. So we've got points on a circle. We've got two different circles. So what I'm going to do is draw them separately. Oh, and we're told that this is the centre of that yellow circle. And we've got another circle over here. Okay. And we're trying to prove an angle. So now we've got to write all those rules out. So every time we use a rule, we've got to write it out now. So what we've got here is we have our, let's have a look. So we've got CEF, which we're told is X. So we're told this one's X. And if you notice, we've got that isosceles triangle again. So that must also be X. So that tells me that's going to be 180 minus 2X, because angles in a triangle add up to 180. We then also know that if that's the case, this is a vertically opposite angle, that's going to be 180 minus 2x as well. Now, if you have a look, we've got a four-sided shape within a circle. Now that is your cyclic quadrilateral. So that's a four-sided shape inside a circle. And what we know about that is that the opposite angles add up to 180. So that must be 2x, and that's what we were looking for. So now let's write that up in a way that you get all the marks. Because at the moment, we've worked it out, but we haven't written out our reasoning and all our different steps in order to get there. So we're going to start off by saying CFE, so it's always the middle one, so C to F to E, equals X, and that's base angles of isosceles triangle. We also know that ECF is 180 minus 2x, and that's angles in a triangle add to 180. And then we can say DCB equals 180 minus 2x, and that's vertically opposite angles. And then finally, we get to BA, what have I written here? BC, that should be a D. BAD, which is 2x, and that's where we write the opposite angles of a cyclic quadrilateral add to 180. Okay, so that's this one here. All right, part B, it says, in the case when AB is parallel to DE, work out angle X. So we're now told that AB, right, so I'm going to take this line here, it's parallel to this line here, and we want to work out X. Okay, what do we notice about DE? So DE goes through the center and it's this circle here. So we know that DE is a diameter. When we have a diameter and it goes to the edge, we always get a right angle. So now we know that we get a right angle there. So the next thing that we can do is we can now say this is a right angle. So if that's a right angle, and we know that this angle is X, and because you have parallel lines, we also know that you've got vertically opposite angles are going to be equal. So if you have a look here, you got like a Z angle, and this is going to be 2x. So that tells me that's also going to be 2x. So what I'm going to end up with there is 90 plus 2x plus x must equal 180. So then we're going to end up with 3x equals 90, so x equals 30 degrees. Right, so I hope that makes a bit of sense. The next section here we've got is geometric proof. Now they aren't that many questions on it, and they all use different methods and different things to get there. But the important things about geometric proof and the things that people get wrong are not writing your proof. So not writing and constructing your argument. So you have to make sure you give reasons. So that's your like pointer number one, not just the angles. So you want the angles and their reasons. And if it's a proof question, you want to go in a logical order. So that's the most important thing here. Okay, so this question here, we've got a rhombus and we want to work out the area. Okay, so this isn't quite a proof question, even though I guess it came under it when we did it, when I looked up questions. So this is using the angles, area of a triangle. So you've got 8 centimeters here. If you have a look, this is actually a rhombus is made up of 2 triangles, right? So if we have a look at ABC to start with, so we've got triangle ABC, we know that the area of a triangle, so one of the formulas we know, and if we don't have a right angled one, is a half AB sine C. Now this could easily come up in a non-calculator because you should know what sine 60 is. So you're going to have a half times 8 times 8 times sine 60. Okay, so we know that sine 60 is the same as root 3 over 2. So we've got a half times 64 times root 3 over 2. And so that's going to give us, that cancels to 32 root 3 over 2. But that's just one of the triangles. We've got 2 triangles and they're the same. So we say the area must be double that, 32 root 3. You can say times 2 and then 32 root 3, which is in the form that they're looking for. Okay, so now we've got our proof question. We want to prove that A to C is a diameter of this triangle. Right, now if it is a diameter, then we would know that ABC is 90 degrees, but we can't assume that. However, we have a circle, and as we worked out earlier, if we have a circle, and inside our circle, we have a 4-sided shape, so we've got a shape like this, opposite ones add up to 180. So we know that this plus this must be 180. So we've got x plus 2x plus 4x plus 3x equals 180. So that gives us 10x equals 180. So x equals 18. Okay, so if we know x equals 18, we now need to find out, and we'd say this is because opposite, because we're in a proof world, angles of a cyclic quadrilateral add to 180. We now should be able to find either CBA or CDA because we know what x is. So we'll say BCA equals 18 degrees. BAC equals 4 times 18 degrees because it's 4x, 72 degrees. That's just substituting the values in. And then we've got CBA equals 180 minus 18 minus 72. Angles in triangle add to 180. So that gives us 180 minus 18 minus 72, which is 90 degrees. And then we can have to write a final sentence, which is essentially going to write this thing. So we say an angle subtended, that's like a fancy word, but essentially the angle at the circumference by a semicircle is 90 degrees, therefore AC is a diameter. And that would be sufficient for you to get all the marks. Okay, topic 3, we've got the sine rule. So that's written in 2 ways, A over sine A, B over sine B, C over sine C. So essentially, when we have something that's not a right angle, so we have a triangle that's not a right angle, we can't use SOHCAHTOA, we can't use Pythagoras. We have to use either the sine rule, or we do a bit later, the cosine rule. And remember, whatever the side of it is, the opposite one is what we represent with a small letter. Okay, so we've got here, we're trying to find angle X. I'm going to label some things. I'm going to call that big A, so that's going to be small a, big B, so that's going to be small b, and we don't need C, we only need a bit of this. Now, because we're trying to find the angle, we can also flip the sine rule and write it this way round. And if we flip it and write it that way round, whenever we're trying to find an angle, use the flipped version. So we're going to use sine A over A equals sine B over B. So we're going to have sine X over 2y equals sine 18 over y. Okay, so hopefully you can see you could multiply this y up here, so we'll get y sine x over 2y equals sine 18. The y's cancel, so sine x is the same as 2 sine 18. This will be in a calculator paper. So x must be shift sine, so 2 sine 18, which is 0.61 something something. Shift sine of my answer is going to give me 38.17. Now that's still not correct because they've asked me for an obtuse angle. And all you're going to learn to do any trig is 2 rules. You're going to say if you see sine, you get another angle by doing 180 take away. And if you see cos, you get another angle by doing 360 take away. So if x is 38.17, it's also, because it's a sine, 180 minus. So it's also 180 minus 38.17, and that's going to give you 141.8 or 142 degrees. Right, another triangle here. And we want to work out the value of x. So what we've got here is another sine rule, and the way, this doesn't tell you to use the sine rule, but hopefully you can see you've got opposites, right? And we're trying to find a side this time, so we're going to write it the other way around. So it's a small b, so we're going to b over sine b equals c over sine c. So b is the x that we're trying to find over sine 45 equals c, which is 6 root 2 over sine 60. Now this is non-calculator, so this is something you should know your sine 45, your sine 60, your cos 45 and so on. So you're going to have x over sine 45, which is the same as 1 over root 2. So x divided by 1 over root 2 equals 6 root 2, and sine 60 is the same as root 3 over 2. Okay, now if we times everything by 2, what's going to happen, just to get rid of like these denominators, because if you, well, let's think about what this means. So if you've got x over 1 over root 2, it's the same as x divided by 1 over root 2, which we change a divide into a times, so it's actually x times root 2. So this is actually root 2x. And the same here. If we were going to have 6 root 2 divided by root 3 over 2, it's the same as putting in a times sign and flipping the second one. So actually, it's the same as 12 root 2 over root 3. Now we want to get x on its own, so we're going to divide. So when we do that, we're going to do root 2, well, there's root 2's on both sides, so we can actually just get rid of those. So we get x equals 12 over root 3. Now if you notice, we don't like surds on the bottom, that's why you do all that rationalising. So we're going to multiply top and bottom by root 3. So we're going to get 12 root 3 over 3, that's going to cancel. Our final answer is 4 root 3. So a lot of those marks are just for manipulating the surds. And once you've manipulated them, you can see that it actually works out quite well, quite nicely. Okay, we all know Pythagoras. A squared plus b squared equals c squared. And we do that using A only if we have a right angle triangle. But when we're squaring something, particularly if we have x's or various numbers, we've got to make sure we square everything. So get used to writing the whole of whatever your A is inside a bracket. Okay, so here we want to find A to C. So we've got a right angle triangle. We're going to do A squared plus b squared equals what we're trying to find squared. So we've got AC squared is 3x, this is what I mean by brackets, all squared plus 4x all squared, which gives us 9x squared plus 16x squared, which gives us 25x squared. And then we're going to take the square root. Square root of 25 is 5, and we get AC equals 5x as we needed to. So that's what we wanted to get, and we've got that now. Okay. Part B, we want to find the area of the quadrilateral. Okay, let's have a look at the quadrilateral. So we now know this is 5x, and they want the area of this entire shape. So 1, 2, 3, 4, which is why it's called a quadrilateral. And so we could say, okay, let's find the area of the other triangle, well, both triangles. We could start with the area of this triangle at the bottom, because it's a right angle, so it's easier. So we've got half the base times the height. So we're going to get 4 times 3, which is 12, divided by 2, which is 6. So the smaller triangle at the bottom is going to be 6x squared. And then we've got this other triangle at the top. Now, in order to find out or do anything with this triangle, we're going to need to find out an angle somewhere. Yeah. So, what do we know? We're told that ACD, we're told this is isosceles. So we know that the base angles here are going to be the same. So the first step we're going to have to do is going to be to find the angles. But because it's an isosceles, what we can also do is split this in half. So we don't need to worry about any rules. And when we split it in half with a beautiful perpendicular line, which mine wasn't, you're going to get a right angle here. And this will be half and this will be half. So as to redraw that triangle, just half of the triangle, I'm going to have my right angle. That's my right angle. Actually, let's draw it the other way so it's facing the same way so you can see what I'm doing. So we're drawing here, here, here. We've got a right angle here. So the angle that I'm drawing is going to be, the triangle, sorry, that I'm drawing is this triangle here, which is going from D, if I call this just sort of midpoint, and C. We know that bit across is 5x, so this must be 2.5x. We don't know the height dm, but we know D to C is 6.5x. Now, in order to find out the area of the triangle, we want to find out this angle here. So we can find out this angle here. We've got the adjacent and we've got the hypotenuse. So using SOHCAHTOA, we're going to use cos. So we can see that cos x equals 2. So cos x equals 2.5x over 6.5x. These cancel. So I'm just calling this angle x. I know it's confusing. We should have probably called it x. Inverse cos of that, it gives me an answer of 67.4. So now I have an angle. I can use that same triangle formula, half base, or half A, B, sine, and then sine C. Right, we're going to stick that all into our calculator. So we're going to, without the x obviously, so 0.5 times 5 times 6.5 times sine of 67.4, which gives me 15.000. And then we've got x, which is x squared. So I'm going to say that's 15x squared. We had this 6x squared from the smaller triangle. So we add them up and we get 21x squared. Okay, the diagram shows a rectangle this time. So we've got a rectangle, we've got some measurements, and we want an expression. So don't freak out if you get asked for an expression for the area. All you're doing is finding something in terms of x and y. Okay. And here we want, in its simplest forms, in terms of only y. Okay. So the first thing we're going to do is we're going to say the area of a rectangle is base times height. So we'll get x times 2x, which is 2x squared. It's the area. But we've got no y's there, and they want it in terms of y's. So we've got to say, what's the connection between the three lines that we've got there? The connection between those lines is Pythagoras. So we've got x squared plus 2x all squared equals 4y squared. So we'll get x squared plus 4x squared equals 16y squared. Now we want to find out what 2x squared is in terms of y. So we've got 5x squared is 16y squared. X squared is 16 over 5 y squared. Therefore 2x squared is 32 over 5 y squared. And that would be our answer. Okay, next question. We've got a cone with a vertex and a centre. The slant height is 20. The angle between VA and VC is 38 degrees. So let's think about what that means. So VA and VC, where do those two lines meet? At V. So this is the angle that's 38. And we want to work out the radius of the base. Okay, so that's quite nice. We've got SOHCAHTOA, right angle triangle. And so what do we have? We want to find the opposite, and we have the hypotenuse. So we know that sine 38 is r over 20. So r must be 20 sine 38. When we stick that into my calculator, I'm going to get, 20 times sine 38. I'm going to get 12.3. And that's going to be the radius of that base. Okay. The next topic is 3D trig. So we often need to find, when we've got 3D trig, what we're looking for a lot of the time is like a triangle floating in 3D. Okay, I'm incredibly bad at drawing this, so let's see if we can draw something, otherwise I'm going to have to show you with an example probably. So if I have a 3D sort of cube, and what I would be looking for, so maybe I need, you'd have, say for example, a floating kind of triangle over here, inside this cube, right? What you have to think of is that everything is right angles. And sometimes they don't give you the side lengths, but they tell you it's a cube. So if they do that, make sure you choose the length to be either 1 or 2. So when you half it, if it's midpoints anywhere, you get to use it like that. So 3D trig is just about creating lots and lots and lots of triangles and remembering there's like right angles everywhere in a cube. Okay, or in a 3D shape. If it's something like this, which is a cuboid. So it's telling you that they want you to work out the length of AB. So let's see what we know. We know that HB is 34. We know that HD is 16. AD is 18. So we've got a few things there, and we want to find out AD. to be. Now what we can find easily, based on the information we have, is D to be, because we've got a triangle here. Remember, everything is right angles when we've got cuboids, and so we can use Pythagoras to find dB to start with. So D to be is going to be dB squared plus 16 squared is going to equal 34 squared. So dB squared is 34 squared minus 16 squared, which comes out to be 900. So dB must be 30. So now we've got 30, and then we've got another right angled triangle. So if we want to find out AB squared plus 18, oh wait, sorry, AB is my hypotenuse. So we're going to have, just again, 18 squared plus 30 squared equals dB squared, right? No, ignore me entirely. dB squared is my hypotenuse. Okay, let's try to do this properly. Apologies for that. Right, where is my right angle in this triangle that I have? I'm going to have dB squared minus 18 squared. So dB is my right angle, because my right angle is here, on the bottom here. See, you can see that AB is going to be your height. Is going to be, so dB is going to be your, oh my God, I can't get my words out today. So dB is going to be your hypotenuse, so which we know is 30, right? So let's rewrite this. Let's go again. Oh, we're going to end up with 18 squared plus AB squared equals 30 squared. So therefore AB squared equals 30 squared minus 18 squared. So AB equals the square root of that. So 30 squared minus 18 squared, which gives us square root the answer, which gives you 24, which makes more sense. There you go. All right, so let me go through that again and hopefully haven't confused you too much. This one at the bottom is your right angle. You're going to have right angles on the sides here and along the bottoms here. Okay, right, so you'll have to excuse whatever confusion I caused. Right, next one. We're going to work out the angle between HB, which is drawn there, and ABCD. Now the nice thing is they've drawn you the triangle essentially. So the angle that you're looking for is essentially this angle over here. So if I was to take this triangle, I know the opposite and I know the hypotenuse. So I'm going to use so sine. So I'm going to have sine x is opposite over hypotenuse. So sine to the minus 1 is going to give you 21.8 degrees. Right, next topic. We've got our trig graphs now. So we're getting there slowly, and my voice is going. So for trigonometry, you've got three graphs. You've got your sine graph, you've got your cosine graph, and you've got your tan graph. So let's have a look at all three of them. So we'll have 1, 2, 3. Okay. So we're going to have our sine graph to start with. So 90, 180, 270, or 360, always between 1 and minus 1. And what you need to remember with a sine graph is it starts at 0 and it's a sine curve. So what you want is you want to start at 0 and you get like a sideways S shape. Okay, so sine, sideways S, right? Y equals cos x starts at 1 and you sort of get a bucket shape. So that's 90, 180, 270, 360. Now tan x is actually the same as sine x over cos x. Now we know it's illegal and totally wrong to divide by 0. So wherever cos x is 0, which is 90 and 270, you're going to get what we call asymptotes. It's definitely not going to go through there. Wherever sine is 0, it's definitely going to also be 0 here. So 180. And so what you get is this weird sort of like curvy graph like this. So those are your three graphs which you need to know because you'll need to manipulate them and do different things to them. Okay, so now we're told that cos 36 equals 0.8090. Okay, so that's somewhere between 0 and 1. Pick a point here. This is going to be 36. Okay. And then they're saying, so what does that mean? So minus is going to be, so this bit over here. Now remember, everything here is symmetrical. So essentially, the space that you have here is the same as the space you have here. So between 90 and 36, you've got 54. So 90 plus 54 is a 144. The other way, exactly the same with symmetry, if you don't want to do that, is that's 36. And therefore that is also 36, right? So we could do 180 minus 36, which gives you 144 degrees. So they're helping you out by giving you the graph there. So anyway, you just need 4 rules, remember, for angles though. Remember, sine, 180 minus x, cos, 360 minus x. Sine and cos repeat every 360, and tan is always plus and minus 180. Okay, so now we've got a graph of sine x. Now this is also going to use function stuff. Now remember, inside the bracket affects the x. X's are like your ex-friends, boyfriends, girlfriends, ex-anythings. They're annoying. They do the wrong thing. So inside the bracket affects the x. It does the wrong thing. If it says plus, it minus, minus means plus. Outside the bracket affects the y. The y does exactly what you expect it to do. So these ones should be nice. Let's have a look at them. We've got a sketch of y equals sine x. So we've got alpha is an acute angle, which means between 0 and 90. So, okay, we're going to pick our alpha. I'm going to say alpha is somewhere here. And we know when we do sine of it, we've got k over here. Right. Now, remember our rule for sine was 180 minus. So if we've got 180 minus, it's just exactly the same answer. Because if we go 180, this is alpha and this is alpha. Going to go up, we're going to get exactly the same response. If we do 360 minus alpha, hopefully you can see it's just going to give you minus k. And then cos of alpha, so what's your connection between cos and sine? So what we need to know is we've got some rules. We've got tan x, we said was sine x over cos x. But your connection between sine and cos is sine squared plus cos squared equals 1. So if sine is k, k squared plus cos squared alpha equals 1. So cos squared alpha is 1 minus k squared. So cos alpha is a square root of 1 minus k squared. That's a little bit mean. We haven't really looked at the trig identities. We're going to start to look at them now. But that's the sort of thing that you'll see. So anyway, trig identities. So let's look at some trig identities now. So if we have a look here, what we've got here is there are 2 main identities you need to know. So what you need to know is sine squared x plus cos squared, and this is just a fancy way of writing sine x all squared. We just write it like that because it looks pretty. Right, so sine squared plus cos squared is 1. Tan x is sine x over cos x. And let's remind ourselves of the other rules. So you've got them all on one page and it makes it easy to see. So remember sine x. So if you have sine, it's always, you find your one answer on your calculator and your next one is 180 minus. Cos, 360 minus. Tan is the easy one. You just keep adding and subtracting 180. Now, if you need more solutions for cos and tan, it repeats every 360. Right. The other thing that you should know is that you should know your geometry, and you may have learnt your angles by heart, but to understand where they come from, you've just got two triangles that you need to understand. One is an isosceles triangle, so two sides are the same. So if that's 90, this must be 45. Using Pythagoras, this is root 2. And that essentially tells us that sine 45 is the same as cos 45, which is 1 over root 2. So that's the first one there. And we can see that tan 45 is going to be 1. The other triangle that we use actually starts its life as an equilateral triangle. So it starts like an equilateral triangle where all the sides are 2 and all the angles are 60. So if you were to prove it from scratch, and then you split that in half and you end up with this triangle that we're going to have here. So that's 1, that's 2, therefore that's root 3. That's 60, so we know that one's 30. And from that we can find our sine 30, which is a half, sine 60, which is root 3 over 2, and then we've got cos 30, which is root 3 over 2, cos 60, which is a half, we've got tan 30, which is 1 over root 3, and tan 60, which is root 3. So those are for your non-calculator paper where you need to learn them if possible. And when you've got trig identities, you'll either get like provey questions or solvey questions. And we're going to come across one of each, some of each, and we'll go through them now. So it first says this is equivalent to this. So we've got to try and make this look like this. So we just take one side to start with. So we're going to take our left-hand side. We can see that we don't want any, this is, by the way, this is not 2, this is a square that's printed very nicely. We don't want any sines. So we look at our rule. We know that sine squared plus cos squared is 1. So that tells us sine squared is 1 minus cos squared, and cos squared is 1 minus sine squared. So we're going to replace the sine squared with 1 minus cos squared. So we end up with 6 minus 6 cos squared x plus 4 cos squared x. So let's simplify that. We can see here we've got 6 minus 6 plus 4 gives us minus 2. So A is 6, because that's the bit that matches there, and B is minus 2. So that's your first sort of type of question, which is sort of an equivalent question where you're matching things up. Now we've got to show that, and again, try to make everything into sines and coses. We know that tan x is sine x over cos x. And then we also know that sine squared x plus cos squared x equals 1. Okay, so 1 over tan squared. So we're doing 1 over sine squared x over cos squared x. Now remember, when we divide, we flip the bottom. That's minus 1 over sine squared x. So when we flip this one, we get cos squared x over sine squared x minus 1 over sine squared x. The denominator's the same. So we've got cos squared x minus 1. And what we can then do is hopefully see that's actually the same as sine squared, because we rearrange that. And that cancels and just gives you 1, which is a constant. So we've proved what we need to prove. Right, so cos squared minus 1, is minus sine x, so we get minus 1. So here's me jumping. Cos squared x minus 1, we'll move that onto that side, will be minus sine squared. Okay. Right, trig equations. So this is what we were talking about, where we've got these rules that we're going to use. Okay, I'm going to keep writing them. Hopefully, if you keep hearing them, they go into your head, and eventually they're going to become second nature. Right. So we've got our trig equations where we're going to use our our rules. So tan x is sine x over cos x, but also we know our 5 rules that helps us simplify things. So we've got sine 180 minus x, cos 360 minus x. These repeat every 360. We've got tan plus and minus 180, and so on. Okay, so we want to show that. So this is another proofy one. We know our formulas, and we sort of go, I'm not really sure, but I kind of want to get rid of the minus 1. So sine squared, but I don't know, there's a few ways you could do it. You could either change the cos squared into 1 minus sine squared, or the sine squared into 1 minus cos squared. And we got to figure out which one, will give you what you need. In this case, they both end up working out for you. But let's change the cos squared into a sine squared. So cos squared is the same as 1 minus sine squared. Right, and the reason I did that is I kind of want the ones to disappear. So I can see there's none on the bottom. So sine x, cos x. So I replaced here, what I've done is taken cos squared x and made it 1 minus sine squared x. And that's because I know sine squared x plus cos squared x equals 1. So therefore cos squared x is 1 minus sine squared x. So these cancel. 2 sine squared minus sine squared is going to give you sine squared x. Over sine x cos x, that's going to cancel, leaving you sine x over cos x, which we know is tan x. So now it's saying hence. You see the word hence, you're using the bit from the question before. If you didn't get it, it doesn't matter. Use the answer that they said show that and put it in. So we get tan x equals minus 1, right? So shift tan in my calculator of minus 1 is going to give me my first solution. So I'm going to do shift tan minus 1, and my calculator gives me minus 45. Right, I think what's my tan rule? So tan is just plus and minus 180, so we can keep adding 180. So to that minus 45, I add 180, I get 135. That's in my range. I add another 180, I get 315. And if I was to add another one, it would be outside the range. And then I cross out that one. So first I have my either 2 solutions if it's sine and cos, 1 solution if it's tan, add, get everything in your range, and then eliminate the solutions which are not inside your range that they've given you. Okay, here's another one. We're going to, I think this is our last question. We're going to show that 2 cos squared theta is equivalent to 2 minus 2 sine squared theta. So we start off with cos squared theta plus sine squared theta equals 1. Therefore, cos squared theta equals 1 minus sine squared theta. So we get what 1 that's cos squared theta, 2 minus 2 sine squared theta, and we've proved what we needed to. And then it says hence solve. So you're like, well, how does that help me? Well, we can see that this must be the same as this. So that's what we replace. So we get 2 minus 2 sine squared theta plus 3 sine theta equals 3. And when we're going to put everything on one side, you're going to get what we call a disguised quadratic. So it's like the equations that you factorize and it's hidden with the signs in there. Okay? So what we've got here is we're going to get 2 sine squared theta, I'm going to move it to the other side, minus 3 sine theta. 3 minus 2 is 1. So I'm going to move everything this side, plus 1 equals 0. And then you could, if you can't see it and it annoys you, you could say let x equal sine theta. So you get 2x squared minus 3x plus 1 equals 0. We could factorize that. So we get 2x and x, 1 and 1. And we're going to get minus and a minus, because that's going to work out. So we get x equals a half, or x equals 1. But x is really sine theta. So sine theta is a half, sine theta equals 1. On our calculators, we do shift sine of a half, and we get 30. The rule for sine, remember, sine is 180 minus. So 180 minus 30 gives me 150. And then inverse sine of 1 is 90. And that's all we need because that's our range. So we've got 30 degrees, 150 degrees, and 90 degrees. And that, hopefully, I know I've spoken for so long, so please, do what you need to there. Use as much or as little as you need. So that is everything we have for geometry. I'm going to upload this just as a screen record at the moment, and we will prettify it and put it up properly for you. But just so at least you've got you've got it there. We'll try get that up for you tonight. Okay, I hope that's useful. Sign up for the course next week if you need it. We'll be going through some more papers and just lots and lots of questions. And what I'm going to try do as well is give you a summary of everything. So just like a really quick summary of some notes, and if you like, almost like a cheat sheet for your further maths. Right, hope that's useful. And any questions, ask away.